Okay, so for question 18, we took a random sample of college students and found that out of 100 college students, 40% have admitted cheating. So that's our p hat, 40%, which is 0.40, which comes from 40 out of 100. Find the approximate 95% confidence interval for the percentage of college students who have admitted cheating on the college exam. So the formula we're going to use is p hat plus or minus z star times your SE. Now, the z star for 95 can be 2, or we can find it more exact. They're basically really close to each other, but this will be an opportunity to teach you how to find the exact z star. Okay, so we have our p hat. To find our z star, remember, what we do is we draw the picture. So 95% would be the middle portion, and we're trying to find the z-score for 95%. Remember, the z-score is the area to the left. So we'd have to find these ends. Now, if we think about it, the whole curve is 100%. So if we do 100 minus 95, that's 5%, but there's two sides. So 2.5 and 2.5. So if you add that up, 2.5 plus 2.5 is 5. 5 plus 95 is 100. So the area to the left would be the 95 plus the 2.5, which would be 97.5%, or 0.975. So if we work backwards, use that percent to the left, then we can find the z-star. So we go to our table, and we're going to look for the closest to 0.975. Now, maybe between two, but we'll find the closest to 0.975. And the closest, which happens to be right here, 0.975. And we're going to work backwards to find the z-score. So the z-score would be 1.96, 1.96 would give us the area of 0.975, 97.5% to the left. So the z-star would be 1.96. That's how we get it. Again, we can use that calculator, that inverse norm, which will ask us for the area to the left, which is 0.975, 0, 1. If we do that in the calculator, we do second vars number 3 inverse norm. The area to the left is 0.975. Mu is 1, standard deviation 0. Again, if your calculator looks like this, is 0.975, 0, 1. Don't need the left part. And you get 1.96. Okay? So we're going to use the z-star of 1.96. So we have the p hat. We have the z-star. All we're missing now is the SE. Now, we did this in previous problems, but we'll do it again. The FC is 0.40, 1 minus 0.40, divided by your sample size. So if we put that in the calculator one more time, square root 0.40, parenthesis 1 minus 0.40, close parenthesis, divided by 100. That gives us 0.049, 0.049. So we have all of our pieces. P hat is 0.40 plus or minus z star 1.96 times your SE 0.049. We're going to do 1 minus 1 plus. So we have 0.40 minus 1.96 times 0.049, and we have 0.40 plus 1.96 times 0.049. We're going to do 1 with a plus, 1 with a minus. So we have 0.40 minus 1.96 parenthesis 0.049. So that gives us 0.30, 0.3, and the 9 rounds up to the 4, so 0.304, 0.304, 0.304. And then if we use that little calculator trick, second enter, we get that back. Change it to a plus, and we get 0.496, 0.496, 0.496. Before we write the sentence, let's check that in the calculator. To check in the calculator, remember they're going to want the x, which is the numerator, n, which is the denominator, and they're going to want to know that the confidence level is 0.95. So in the calculator, we're going to do stat over to test, all the way down to A, all the way down to A. X is 40, N is 100. This time the sea level is 0.95. Go to calculate. 0.304, 0.496. Matches what we have, or very close. So we can write our sentence. We are 95% confident the proportion of college students who admit cheating on exam is between 30.4% and 49.6%. Again, we're 95% confident the proportion of college students who admit cheating on an exam is between 30.4% and 49.6%. Okay, last couple questions. What happens to the confidence level as you increase the confidence level? So let's see what happens. So notice that we started with 68 and the interval was about 35 to 45. Then we went to 90 and the interval went from 32 about to 48. And then as we went to 95, the confidence level is increasing, and then it's now about 30 to 50. So what happened? The confidence interval gets wider. Now, why does the confidence interval get wider? Well, the math answer would be that your Z star increased. So if we look at it, P hat and SE were the same for all of them. P hat, SE. P hat, SE were the same for all of them. What changed was the Z star went from 1 for 68, 1.645 for 90, and about 1.96 for 95. So that's why also think about it, you become more confident the wider the interval is. More confident the wider the interval is. And then the last question goes to those big ideas we talked about in chapter 7. So true or false? Statistics vary from sample to sample. That is true. The size of the population does affect the precision. That is false. False. The size of the population does not affect the precision. And large samples produce more precise estimators. That is true. The larger the sample size, the more precise your estimate is.